Welcome to Lesson 6.1, which deals with measures of central tendency. Before we begin measures of central tendency, I'd like to review just a couple questions from the Lesson 1.5, which dealt with scatter plots and positive, negative, and no correlation. Let's look at homework question number 21, and it asks us to think about a survey in our state and what would you expect the relationship between the number of students and the number of teachers to school, in a school be. And if you think about it, the more students you have, what would you expect to happen? Would you have more teachers or less teachers? And we would expect to have more teachers as the number of students increase, and therefore that would be a positive correlation. And we can see that graph that I have right here that kind of shows that positive correlation to what we would expect. Remember, positive correlation S1, as the independent increases, so does the dependent. Question 24, here we have the evaluate the expression. Remember, we're plugging in 3 for M in this situation here. So we have to write 3 for all of the M's, and then you want to follow your order of operations. So we want to compute parentheses first. So we're going to work with inside both of the parentheses. So we're going to work with inside here first and here as well. We're going to work within those parentheses, and we have to follow order of operations inside the parentheses as well. So we're going to square this 3 first, and we get 9. And then we follow order of operations, which tells us we have to do the multiplication before we do this addition. So we multiply and we get the 18 plus 5, which is 23. Over here in this separate parenthesis, we have 3 plus 1, which is 4. So now we get rid of all of the parentheses, and we're left with 23 minus 4, which is the 19, which is answer G. Great job on the homework yesterday. Moving on to central tendency. Central tendency is how we describe data. We use measures of central tendency to describe data, and we have lots of definitions here for you. As always, you're welcome to write down the book definitions. You can kind of summarize what I talk about, or you can copy down what I have here on the notes as well. It's up to you. Just make sure you understand the difference between all of the measures of central tendency. So our three main measures of central tendency are mean, median, and mode. Mean, in order to find the mean, you're going to take the sum of all of your data and you're going to divide it by the number of data points that you have. That's going to give you your mean. Another name for the mean is the average. And then we use the mean as a measure, the best measure of central tendency when we don't have an outlier. An outlier is like one of those weird numbers, and we'll talk about that in a formal definition here. But an outlier is one of those numbers that kind of is way out there. Let's say we have test scores, and all of a sudden we catch someone cheating and they get a 0. Their score, everybody else in the class got A's and B's and C's, but we have this 1 0 because the student was cheating. That 0 would be considered an outlier, and it's going to change that average or that mean dramatically if we look at the class averages or the class mean. So we don't want to talk about the mean when we have outliers like that. We then, here's an outlier. It's a data value that is either much higher or much lower than the other data. And there are some definitions for it. I always just say kind of graph it and look at it. If it looks like it's sticking out, then it's probably an outlier. There is formal definitions for it about how to calculate it, but that is actually not agreed upon in a lot of math circles. So we won't worry about that for this. I'll let your statistics teacher talk to you more about the formal computation for outliers. We then have median. The median is the middle number of data. So if you arrange your data from least to greatest and you start knocking off one at the top and one at the bottom, what's left in the middle is going to be your median. That's the middle number. Now, if you have two medians, you're going to have to average the two middle data values together in order to find that median. If you have an odd set of data, it's the one that's left after you start knocking off the top and the bottom each time. And we're going to use a median. A median's better when you do have an outlier to describe the middle of your data when you do have an outlier. And then our final is the mode, and the mode is the most frequently occurring. The mode is the most frequently occurring and that it is possible to have more than one mode, and it's also possible to have no mode if all of the numbers appear evenly. You're going to use modes most when you have non-numeric data, like when choosing a popular item of some sort. Modes are great, like your favorite color. You're gonna not look at, well, the average is, because you don't have an average usually. So mode is often used there, and it's the most popular. Measures of central tendency are used to organize and summarize data. The other piece of information that's important about measures of central tendency is a range. A range is this, the range of a set of data is the difference between the maximum and the minimum. And I have seen in many math books, again, where you put like 10-90, and that's your range. Your range is not that two number, it's the difference of those two. So you have to make sure you take the maximum and subtract it from the minimum, and that is your range. So if you had, if your numbers ranged from 10 to 90, your range would be 90 minus 10, which is 80. So your range would be 80. That tells us that the numbers can vary from by 80 points. And then stem and leaf plot is a way to represent data, and I'll show you how to make a stem and leaf plot here in the next page. If you need to take a minute, go ahead and pause while you copy down these definitions and take some notes on that information. Moving on, applying measures of central tendency. So we need to find the mean, median, and mode of the data, okay, and which best describes the data here. So we have some numbers, and we're going to find the mean first. So we add up the number of numbers, and then we divide by the number of numbers, and we get 10.125. The median is the middle number, and the middle numbers, if we arrange it from least to greatest, is going to be between the 11 and the 12, so it's 11.5. And then the mode, since there is no number that is the most frequently occurring, we're probably going to not worry about the mode too much. Now, which is the best? The mean is 10.125. The median is 11.5. There is no mode. The mean is less than 5 of the data points because we have this 2 and the 3. If you look at it, here's our mean is 10.5. There's only, our mean is right around here somewhere, and look at all of these numbers that are kind of above it. A lot of the numbers are above it. So in this case, the median, the middle number of 11.5 is probably a better indicator than the mean here. And again, it's because this 2 and the 3 are kind of stuck down here, pulling everybody else down with our mean. So the median is a better option here. And we don't have a mode, so we don't have to worry about that. So let's suppose you're in science class and you have 3 tests, and you want to know what you need to get on that 4th test in order to get an average of a 90. So we can write the equation here, 82 plus 94 plus 89 plus x equals 360. And where did I get that 360? Well, that 360 is the number of points, or the total. If you were to take 4 90s and add them up and then divide by 4, that's the 360. That's that magic number. So that's the way I look at this this type of problem. So then, well, if you've already earned an 82 and a 94 and an 89, what do you need to get on that 4th test? So all of those would add up to 360, and that would be 95. This is great to do when you're trying to figure out your class, what you need to get on a big test or a midterm in college. A lot of times they have only a couple tests like that, and so it's really easy to figure out what you need to get in order to get the grade you want. Moving on to, nothing there. Moving on to stem and leaf plots. Stem and leaf plots, if you look here, we have a set of data for the stem and leaf plot. Here's our set of data. So our stems are going to be the tens digits here. And then our leaves are going to be the units digits of these numbers. So a 56, we put a 6 in the 5 stem here to represent 56. You always want to arrange your stem and leaf plots in order from least to greatest. Okay, it's really important that way too. And you just go through, and so here's 44, so we would put a 4 in the 4 column that represents the 40 there. It's important with a stem and leaf plot to write down a key, so 5-1 would mean 51. And again, here's our tens units, here's our tens place value, and here's our units place value. Go ahead and take a minute and work on the quick check. When you're finished with the quick check, come back and check your work. So we're looking at, here's the graph, and we want to figure out which is the better set of data here. And so we have, if we find the mean, our mean is 652. Our median is going to be between 625 and 650 or 637, and then our mode is 625. So now, which measure best describes this data, and then explain why? I could probably be convinced by a couple of them. However, if you look at the mean is 652, which if you look at your graph will be right here. There's only 2 data points that are above that 652. And then the rest of the data is below it. So really, in this case, the mean is not going to be really helpful because of these 2 numbers that are kind of pulling that data up a little bit. So the mean, you probably couldn't make a strong case for being the best measure of central tendency. However, the median and the mode would better describe this. And in this case, remember, mode is used when we have categories. And while we have numbers here, you know, a 625 as opposed to a 650, I would consider almost these a little bit of categories too, in that you're chunked here. We don't have a continuum scale from 625 to 650. You're either chunked here or here. So I think the case could probably be made for either the median or the mode to be the better measure of central tendency as opposed to the mean. The mean is definitely not a good choice in this case. However, you could make the case for either median or mode, whichever kind of you prefer. Question 2, you've got this exam in social studies now, or history, and you want to figure out your 4th one. And we can see here from our data that if we start doing the calculations, she wants a 92 average here. Okay, so the student wants a 92 average, which means we need to get 368 points because 92 times 4 is 368. And so our 4 tests have to add up to 368. And we can see here that she earned 264 points already based on her 3 tests. So her next score would have to be 104 in order to raise her average to a 92%. So unless there's extra credit, and they tell us actually that the highest possible is a 100%, there's no way she's going to get that 92, and she's going to be left with an A- on her report card, which is not bad. But so we can see here how it's not really possible. It's not an attainable goal in this situation. Please, as always, if you have any questions, let me know, send me an email, or talk to me in class. Thanks.